Hello and welcome to the Django GraphQL Query Fundamentals course. My name is Xander. This tutorial is part of a whole course playlist available for free on YouTube. For deeper learning, the extended course is available for purchase at Udemy. Now you'll find all the resources and links in the video description. And don't forget to subscribe to the channel for weekly promotions, discounts, and Udemy course giveaways. In this tutorial, I'll walk you through how to install and set up Docker Desktop and work through a few basic essential Docker terms, image, container, volumes to help you understand the basic concepts and tools you'll need to start working with Docker. This tutorial makes the assumption that you are completely new to Docker, so let's first of all discuss what is Docker. Well, Docker is a tool, a very popular tool, that helps you run applications in something called containers. So a container is a lightweight, isolated environment that includes everything your app needs to run, like the code, libraries, and settings. One of the main benefits of using Docker is that we can set up our app and our app environment the same way on any other machine that is running Docker, whether it's other developers or potentially the production server that ultimately then runs and serves our application. And we can do this without needing to adjust any settings. So for example, let's think about a traditional approach to developing an application. We have our PC, our computer device, and we go ahead and we install the software, dependencies, libraries that are needed to run our application, so our software, and then we go ahead and we build our application within our local machine. Now you can imagine if you are a developer working on multiple projects, you might need to install multiple programming languages, multiple applications, multiple libraries, and you can imagine that can get quite tricky to manage over time. Let's also remember that potentially this application that we are developing is also going to be developed by others. So that means that others will have to also set up their device with the same software, and potentially then they can go ahead and start to develop the app. And of course, like I said, these dependencies, these libraries, these settings need to be exactly the same on both machines in order to ensure that the application works successfully. You can imagine someone else running a different version of software and they start developing and they develop that software for that particular version. Say call that version 2, and over here this developer is only using version 1. That's where issues can start to occur. So with Docker, we are building applications and running our applications inside of a container. And like I said, a container is an isolated environment, or we can think of it as an isolated environment on our computer that includes everything our app needs to get running: the code, libraries, settings. So on our machine in this Docker environment, we go ahead and within our machine we install Docker, and that gives us the capabilities of building these containers. Okay, so these containers, like I said, hold everything, all the settings, all the application requirements and dependencies is needed to run the application, which means that if anyone else wants to run this application and set up this environment, all they need to be able to do is to copy this container over to their device, and they would have the exact same setup then for them to continue developing or testing the application. Now for new developers, Docker can seem a little bit daunting, but hopefully by the end of this course you'll see how easy it is to work with Docker and how convenient it makes the development process. Okay, so let's get Docker installed, and then we can talk a little bit more about images, containers, and volumes, and I'll quickly show you around the Docker Desktop tool that we're going to install and use to familiarize ourselves with some of the tools and features that it provides. In order to work with Docker, typically we would download and install Docker Desktop. So Docker Desktop is a convenient UI tool which is going to allow us to interact with Docker to manage containers, images, and volumes. So let's go ahead and download Docker Desktop. Now I've typed in Docker Desktop into Google, Just go over to the main Docker desktop website. It's going to look a little bit like this. So this is docker.com products Docker desktop. And from here, we simply just need to download. So if you scroll down a little bit, it should be available, Docker desktop. And you can see Docker is available for both Mac, Windows, and Linux. Right, so I won't take you through step by step because this is a really simple process. Go ahead and download, go through the installation process, and then start Docker desktop. Right, so now we have Docker desktop installed. Let's just familiarize ourselves with the terms image, container, and volume. Life in Docker starts as an image. So a Docker image is, let's think of it like a template. I like to think of it like a frozen pizza. It includes everything your app needs to run, such as your code, dependencies, and programming language runtime, and any other environment settings. So like I said, think of this like a pizza, a frozen pizza. It has everything you need to actually cook the pizza. All we need to do is put that pizza or Docker image in the oven, warm it up, and then it turns into a pizza that we can actually consume. In this case, in Docker uses images to create containers, which are the actual running instance of our application that we want to run or interact with. In addition to developing our application in a container or running our application in a container, we can also run other applications in containers. So if you think about the development process, typically we're going to need some sort of database. So we can run a database in a Docker container. So let's head over to, I'll spell this right, Docker Hub. So Docker Hub, this is where we'll find a library of images which we can download and use. So let's have a look at Postgres. So Postgres is a database that we're going to use in this course. So I head over to Postgres. Always try and make sure that you're working with Docker official images. And then from here, we can determine which version we want to download, which image we want to download. And then that image will ultimately then be used to create a container, a running instance of Postgres database. Okay, so we have an image and then we have a container. So remember, a Docker container is the actual running version of the Docker image. So while the image is just a template, the container is a live working environment created from that template. Each container is isolated, meaning it runs independently with its own set of files, settings, and dependencies. Containers are lightweight. They share the system resources efficiently, which makes them fast to start and stop. You can run multiple containers from the same image, and each one can be started, paused, or removed easily, all without affecting the original image. Ultimately, this is a simple, consistent way to run applications without worrying about what's installed on your system. So the general workflow here is that we would download images from Docker Hub, and we can do that programmatically. Now these images will be managed, or we can manage these images within our Docker desktop application, which we will see shortly. So we go ahead and we bring our image into Docker desktop, and then from Docker desktop, or programmatically, we can then turn these images into running containers. So within Docker desktop, we can then go ahead and manage our containers, start, stop, pause. We can do all this programmatically, like I've been alluding to, but using Docker desktop is an easy, convenient way of managing our images and containers. So let me just give you a brief overview of images, containers, and volumes here in Docker desktop. 3 sections. We can access these sections on the left-hand side here. You can see that I already have some images downloaded. From here, I can easily manage these images. I can delete, I can run them from here, which we won't be doing in this course. And there's some additional information regarding the resources that they are currently taking up. Eventually, we would turn these images into containers. So in the container section here, you can see that we have a number of containers running. We have this project called Django ORM course, and it looks like we've got 2 containers here, inventory DB and our Django app. And these are the 2 containers that are currently running. So I can further inspect containers. If I click on the container, I can then go and have a look at the logs of this particular container. So this is like a computer, a server inside of my machine. Obviously, it's running in this isolated container. So it's working like a general computer. It's got an output here. I can take a look at the files that make up this container, and I can also interact with it. Who am I? So this is the command prompt for this particular container. As we work through the course, no doubt we will be interacting and using those tools. If I want to start, stop, or manage my containers, I can do it from right here. So on the right-hand side, I can delete, I can stop, and I can then go ahead and pause. Docker Desktop makes it easy and convenient for me to perform those operations. But like I said, we can also perform these operations programmatically. Now, one thing we need to understand about a container by default is that this container doesn't persist after we've deleted it or removed it or stopped it. So if we were to, for example, create our Postgres database container, create some data, once we delete that container, the data is gone. Okay, so the data doesn't persist by default. So in order to persist data, to ensure that when we save data or perform actions within the container that it's stored, we're going to need to set up volumes. So a volume is Docker's way to store data outside of the container. This matters because, like I said, by default, any data inside the container is temporary. It's lost if the container is stopped or removed. So volumes solve that. Volumes keep our data safe and persistent even when containers are deleted. They're especially useful for things like databases, logs, or any files your app needs to keep over time. You can also share volumes between multiple containers, which is helpful when apps need access to the same data. Now, there are multiple types of volumes that we can set up, and depending on how we need to interact with a container will depend on what type of volume that we create. If we go back into Docker Desktop, we can see that when the resource is live, for example, our container, we can see that we have this green light indicating that the container is live and it looks like it's working successfully. So that's the same with volumes. So you can see this green light denotes the fact it's in use. So if I were to try and delete it, well, that wouldn't be possible. Same with images. Notice here we have this green light indicates it's in use. If I were to try and delete images, I couldn't do that. So if you do want to delete anything, you need to make sure initially that the container has stopped and has been deleted, and then you can go ahead and delete volumes and then the image. Right, so that's the real basics of Docker. Images, containers, and volumes. And of course, now we have set up and configured Docker Desktop, and we're now ready to move on to actually start to build our images and containers for this course.